Hi, I'm here to discuss about the general structure of alkenes. First, in organic chemistry, an alkene is an unsaturated hydrocarbon that contains at least one carbon double bond. The words alkene, olefin are used often interchangeably. The alkenes comprise series of compounds that are composed of carbon and hydrogen atoms. With at least one double bond in the carbon chain. The group of compounds comprises homologous series with a general molecular formula of CnH2n, where n equals any integer greater than 1. The simplest alkene is again ethene that contains two carbon atoms. The molecular formula is C2H4. The structural formula is.
Hi, I'm here to discuss about sample naming of alkenes. So the first 20 chain alkenes is ethene, and the molecular formula of ethene is C2H4 propene, C3H6 butene, C4H8 pentene, C5H10 hexene, C6H12 heptene, C7H14 octene, C8H16 nonene, C9H18 decene, C10H20 undecene, C11H22 dodecene, C12H24 tridecene, C13H26 tetradecene, C14H28 pentadecene, C15H30 hexadecene, C16H32 heptadecene, C17H34 octadecene, C18H36 nonadecene, C19H38 acosine, C20H40. So that's the first 20 chain alkenes, and I have here the example for you to understand. So hex 1 in hexene because there are 6 C6. Second example is 4-methyl hex 1 in hexene because 4 is 1-methyl. The third example is 4-ethyl 2-methyl hexene 1 because of 4-ethyl 2-methyl and hexene. That's all.
Hi, I'm going to discuss about common properties of alkenes. Alkenes contains a carbon-carbon double bond. This carbon-carbon double bond changes the physical properties of alkenes. At room temperature, alkenes exist in all three phases: solid, liquid, and gases. However, these isomers is lower than the melting point than the trans isomers. Alkenes are a family of hydrocarbons containing a carbon-carbon double bond. Ethane, C2H4, propene, C3H6, and we can use this formula CnH2n, Cn2n.
Hi, I'm going to discuss to you the IUPAC procedure for naming. So, the names of the straight chain saturated hydrocarbons for up to a 12-carbon chain are shown below. The names of the substituents formed by the removal of one hydrogen from the end of the chain is obtained by changing the suffix ane or YL. So, for one carbon, the name is methane. For 2, ethane. 3, propane. 4, butane. 5, pentane. 6, hexane. 7 is heptane. 8 is octane. 9 is nonane. 10 is decane. 11 is undecane. and 12 is the decade. So I'm going to discuss to you the other thing that I'm going to discuss to you is the rules to follow. I'm just going to discuss 2 rules, and then the following rules will be discussed by Justin Caps. So the first rule is identify the longest chain. This chain is called the parent chain. Number 2 is identify all the substituents. Groups of substituent is groups appending from the parent chain.
I'm here to continue the simple list of rules to follow. Number 3. Number the carbons of the parent chain from the end that gives the substituents the lowest numbers. Number 4. If the same substituents occurs more than once, the location of each point on which the substituent occurs is given. Number 5. If there are 2 or more different substituents, they are listed in alphabetical order using the base name. Number 6. If the chains of equal length are competing for selection as the parent chain, then the choice goes in series to A, the chain which has the greatest number of side chains; B, the chain whose substituent have the lowest numbers; C, the chain having the greatest number of carbon atoms in the smaller side; and D, the chain having the least branched side chains. And number 7, a cyclic ring hydrocarbon is designated by the prefix cyclo, which appears directly in front of the base name.